Hi, welcome to the Introstat lecturing series. And this is a midterm exam number 2 review. This is the second part of the midterm exam number 2. For the first part, we work the problem number 1 all the way to problem number 17. So for the exam number 2 review, we will continue the problem number 18. Okay, let's go to our practice exams here. Okay, so for the number 18 here, so they said a student in an introduction STEP course was asked to describe their political view as liberal, moderate, or conservative. So here is the contingency table showing us. I want to produce a graph to display the conditional distribution of the male and the females, right? So be careful. Here, I want to do the conditional distribution of the male and the female. And then among the 3 categorical variables here, among these 3 categorical political views here. So that's why I want to see, for the male and the female, is their political view as liberal, moderate, or conservative? Are they independent or not, right? So that's why if you look here, so I know my conditional variable would be the male and the female. So it will be either A or B here, right? So it will not be C and it will not be D here, because I want to see for the male and the female, that's what is a condition for the male and the female, then the political views here. So if you take a look at this is the, this is the, for example, this is the labels, right? So this is a label between the male and the female. And then also like for the females here, if you take a look at this ones here, so liberal is 35, moderate is 36, and conservative is 9 here. So by looking the graph, so I know which one is right. So this one will be the correct one. So this is a 35. So this bar is about a 35. So this bar is a little bit more than it's 36. This is nice, right? Then this is a 35, 38, 22. So I know the B will be the correct answers, right? So even the A is both the female and the males, right? But then the number doesn't match. So for examples here, the liberal is higher than the moderate. That's not right, because here the female's liberal is a little bit less than the moderate, right? So I know this one is not correct. So the correct answer will be what? Will be B here. Okay, so be very careful, right? So when you read this, you need to see which one is which, okay? Number 19, they said, assume the cholesterol level for the adult American can be described as a normal models here, okay? With a mean, so what is the means here? Mean will be 180 milligram, and the standard deviation is 20. So what percent of the adult women do you expect to have cholesterol below 170? Like we say, when we do this type of the problems, we always graph, right? So here is what? Here's my mean. So it's 180. I want to see the cholesterol below 170. So this is below 170 here. Correct? That means I'm looking for this area below. Okay, so in order to get this area, so let's go to our calculator. So let's see here the calculator. So now here we said, okay, so let's see here. So, okay, that's clear. So we do the second bars, then the normal CDFs, right? So you hit the CDF because we are doing that light, the light pink area. So the lower bound is to the negative infinity. So the up bound is what? It's 170. Then what is my mean? My mean is 180. What is my sigmas here? Sigma is 20, right? Then you do a pace. So it's 3085. Okay, so let's go to here. I find a 3085. So from the calculator, this gives me the 0.3085. So which ones here will be our answer? So the answers here will be the D's here. Okay, so the next ones here, they say above what value are the highest 10% of the women's cholesterol levels here. So you do like this, right? So this is 180. Then you want to find what is this values here, right? Kind of similar like z-scores here. You want to find what is this value. It will be the highest 10%. What means the highest 10%? That means these areas here, right? This light blue area is what? This light blue area is 10%, right? So it's 0.1. And so I know if I want to find the value of x, I need to use inverse norm. But for the inverse norm, the input is always always to the left. So the left to the dotted line is this yellow area, correct? So if the light blue is 0.1, what is this yellow areas here? It's 0.9 here. Okay, now let's go ahead and go to our calculator again. All right, so here let's take a look. So I do the second bars. So because I'm looking for similar, like find the z-score, so I use the inverse norms, right? So remember the area is always to the left about what the point I want to find. So this is 0.9. Then what is the mean here? The mean is 180. And what is the sigma here? Sigma is what? Sigma standard deviation is 20. And then you go here. Then it's 205.63. Okay, so it's 205.63. So let's go back to here. So I find out that this is 205.63. So which value is the closest to the answer? Is it your rounding? So it's what? It's 206, right? So will be C here. Okay, now next one's here. So number 21 is here. So during a recent year, the average cost for making a movie is $62.8 million. So let's highlight it. That means the average cost to make the movie is 62.8. This year, I'm taking a random sample. I'm taking a 20 recent action movie, has an average cost is 58.3, and the standard deviation is 77.2 million. And then let's say at the level of 0.05 level of significance, what can be concluded? So can it conclude the cost is less than the averages of an action movie? What are the hypotheses? Okay, so the reason why I'm highlight in the different colors, right? So I know this one said this is the recent years, the making the movie is 62.8. So this is my what? Mu zeros, right? Then all this green, those are my what? From my sample. The sample data. So I take 20 movies, the average is 58.3, and the standard deviation is 7.2. And then I want to test what is the test condition, the 0.05 level of significance, to see the cost is less than. So remember, we always do this, right? So it's mu equal to the mu zero, then the alternative is less than is mu zero. So for here, our mu zero is 62.8. So what will be the answers here? Will be what will be A's, right? So this will be equal to the 62.8 and less than 62.8 here. Okay. Okay. Now let's say what is the value of the test statistics? So first, let's decide what we know about the test, right? So then we can know, choose the correct test. So in here, this is one sample. This is the one sample test, mean test, right? So in here is the population sigma is known or unknown. So here, remember, see here, that's what I highlighted. From the 20 movies, I got the average is 58.3 and the standard deviation is 7.2. Okay, so this 7.2 is what? This 7.2 is S, is the sample standard deviation, is from this 20. So I know what I know here. I know in here, the population sigma is what? Is unknown. So if it's unknown, so what the test we use here? We are using what? The t-test, right? All right, so we're using the t-test. Okay, so that's the first thing we need to decide. Okay, so now let's take a look here. So now let's go to our calculator. Okay, we do the t-test, right? So clear that. So we do stat, then we go to test. So we do what test? T-test here. All right. So I'm using the raw data or statistics. I'm using the statistics. Okay, so move the cursor here and I hit enter. Okay, so they say, okay, now what is the mu zero? So the mu zero is 62.8. And what is my average is here? 58.3. All right. So what is my, what is the sample standard deviations here is 7.2. What is the sample size? 20. I'm looking for is less than, so it's the middle one. So I highlight that one. Then I go down. All right. So here, right? So the test statistics here is negative 2 pointer. So this one's here. This one. Okay, so this one, this is my test statistic, negative 2.795, right? And then this number, this P, this is my P values here, right? So I know my test, so I know my test statistics here. So my test statistic T is 0.2, negative 2.795, and my p-value, let's write it down so we can, so it's 0.00577. Okay, so now let's go back to my worksheets here. Okay, so I wrote that down. So I said, what is the test statistics? So we said the test statistic is the t-test, right? So it's negative 2.795. So your rounding is negative 2.8. So it's what? It's a C, right? Then the p-value, p-value is here. So they want to find the critical value. Let's go back later. So let's highlight the p-value. P-value is 0.00577. So which one is the closest one? If you're rounding, it's 0.006 here. All right. So now let's go back to see the critical values here. Okay, let's go to the calculator again. Okay, so here, in order to get the t values, right? So I do the second bars, and then I need to use the inverse t's here. Okay, so here let's make sure we know what's going on. So a while ago we said this is less than, right? So we need to be careful. So we say it's less than. Okay, so that means you are looking for here, right? It's less than, it's left tail test. And we say it's a 0.05%. So this area is a 0.05. So Now I'm finding the critical value. So here's my critical values here, right? So this will be my critical value. So remember, I always input the left, right? So the areas here will be what? Areas here is be 0.05, right? 0.05. Then the degrees freedom, so let's say it's 20. So it's -1 is what? It's 19 here. All right. So that is why, okay, let me erase this so we can see the output here. Okay, so now you do like a boom, boom, boom. So it will give you negative 1.729. All right, so it's a negative 1.729. Okay, let's go to my workbook. So here it will tell me my critical value is negative 1.729. So when I round it off, so what is my answers here? It's negative 1.73. Okay, so now let's take a look. So what is the conclusion? So this is what we learned from the previous lectures. So the p-value is 0.006 is less than my critical value 0.05. So if it's less than, that means I'm in the rejection regions, right? So what do I do here? I reject what? H0. So if you reject H0, take a look at our hypothesis. That means you are supporting the alternative hypothesis, right? So the answer will be the data provide significant evidence to support the cost of making the action movie is less than 62.8 minutes. Let's see which one is that. Okay, so that's what tell me is here. The data provide significant evidence to support a claim. It costs less on the average to produce an action movie. Yeah, that is the right. Okay, so that's what we mean to reject H0. Okay, number 26. Okay, so they said, okay, so the data set is here. State exam has 3 variables. Sex, the variable sex, the GPA, and the class. If we want to do a dot plot for the female freshmen, here's GPA. So which of the following code is a correcting code to use to filter? So I want to filter 2 things, right? I want to filter female, and also I want to filter what? It's a freshmen, right? So we know the filters here. You know, the one key things about the filter is the equal signs, right? So has to be equals, right? So has to be equal. So that means the sex here is equal to the female, and the class is equal to the freshman here. So my answer here will be part of this here. Okay, that's just a simple R kind of the coding part. We use this filter many times, right? So we said if it's a categorical data, right? So we use the equal, then the quote inside, right? If you have a quantitative type of data, for example, age, the age is a quantitative type of data. Then when you still say age will be equal. So if you said when the age equal to the 30, I want to call that. Then you will just say the 30. So the equal to the 30, you don't put the double quotes here, right? Because this is a quantitative type of the data. Okay, let's take a look at number 27. So they said that the Center Disease Control Prevention report a survey of a randomly select Americans 65 years and older, find 560 of the 1,024 men and 535 and 170, the women suffer from some kind of arthritis. Does this suggest that, okay, so what we are testing here, that is more likely, so the arthritis affect men more than women. And I'm testing at 1% level of the significances here. So what is our hypothesis? H0 is man equal to woman, right? So I want to find is the man is less than woman. So which one is the man less than woman here? So the man, the more affected man more, so man greater than woman. So this will be part D. Part B is here is man, percent of the men greater than percent of the women here. All right. So why the part D is not true? This is the percent of the men greater than percent of the women. We said the non-hypothesis should always be equal. You cannot have lessness there. Okay, so the answer is B here. Okay, so now I want to find what is the value of test statistics here. Okay, so what type of the test, right? We are talking about a proportion test, right? So this is the two population what? Proportions, right? So the two population proportion, what do we use? We use z-test. Okay, so now let's go to our calculator. See how do we input. Okay, so here, clear, I'm going to do a stat, I'm going to do a test. So we just highlight, so what type test we have? Two population, two proportion z-test. So it's number 6, you hit enter. Okay, so the first one is here is men, right? So you put a 560 men over how many I have? 1024. How many women? 535. What is the total? 1070. Okay, so we are testing men more than women, right? So what is here? We have here P2 here, right? P1 greater than P2. So now I calculate that. Okay, so now my test statistics are here. Let's try to write it out. All right, so the test statistics is z-test. So what is the z-test here? Is 2.146, 2.147. And then the p-values here is 0.0159. P-value is 0.0159. Okay, now let's go back to the practice exams here. Okay, so I just wrote it. So the value of test statistics is 2.147. So what is here is A. And then let's take a look at the p-value. So what is the p-value? 0.0159. 0.0159. So it's B here. Okay, now let's take a look at the critical values here. Okay, so I'm doing what? I'm doing at the percentage, the 1% significance level. Okay, so let's go to do the calculator. Let's see here. How do I do that? So clear that out. So I will say here is off second bars. Remember, this is a z-test, right? So I need to use the inverse norm. Okay, so here, let's take a look. Be careful before we are input, so we know how to input here. Okay, so we said is P of the man greater than P of the woman. So we are looking for what? These tails, right? So it's right tail. That's what we say is right tail. And what is the significance level? Is 1%, so 0.01. Correct? All right. And now I'm finding that this value, this is my critical value. So remember we said, when you use the inverse norm or inverse t, we always need to find is all the value to the left. Right, so this is 0.01. So what is my areas here? I need to input 0.99, right? So because this is a standardized normal, so it's 0, 1, and let's see what do we have here. We got a 2.326. So if I try to round it off, so this will be close to the 2.33, right? So it's 2.33. That is my critical value. Okay, let's go back to the exams here. Okay, so it's a 2.33. Do we have 2.33? Oh, yes, here. So we have a 2.33. We have a 2.33, right? So this will be our answers, right? So it's 2.33. Okay, so now let's take a look. So what is the conclusion before we even read it? All right, so let's take a look. My p-value is 0.015. So it's greater than 0.01. So if it's greater than 0.01, what is we conclude here is a fail, right? So it's a fail to reject H0s, right? Okay, so if it is less than the significance level, we fail to reject H0s here. Okay, so now let's read. All right, and so here they say the data does not provide significant evidence to support a claim men suffer some kind of form of arthritis more than women at the 1% significance level. Huh? Yeah, let's look like our answers here. So it's a part A. Let's try to read others, see what is wrong with them. So the second one is here, it says here, data does not provide a significance level to support the claim. The men suffer more arthritis at 5%. Wow. So here, I know the p-value is 0.015. So 0.015 is less than 0.05. So if your significance level is 0.05, because your p-value is less than, so what are we going to do here? We're going to reject H0, right? So that means we're going to have a sufficient evidence to say man is more than. So this is the problem. Okay, let's see here. They say data provide significant evidence to support the claim that the woman suffer some kind of form of arthritis more than men at both 5% and 1%. No, that's not. All right. So it's not a suffer at the both. So they say the data provide significant evidence to support the claim that women suffer more kind of arthritis more than men, only at 5%, not at 1%. That's not true. Women suffer more. That means women suffer more than the men, right? So that means P woman greater than P man. But our testing is P man greater than P woman. So this is not true, neither. Right? So the part E is not true, the same reason. So that's why the part A is the correct answers here. All right, let's take a look at our last few problems here. I think that's it, right? So, okay, so in here we say in the 1980s, it was generally believed that the congenital abnormality affect about 7.5% of large national children. Okay, so let's highlight. So the overall is 7.5. Some people believe that the increase in the number of chemicals in the environment has led to increase in the instance of abnormality. So a reason randomly examined 400 randomly selected children and find 34 of them show the sign of abnormality. Is this stronger evidence that the risk increase? All right. So we said here, what do we try to test this here? We said that the increased number of the chemical also increase the instance of abnormality. Okay, so I know I'm doing the H0, P equal to the P0 Now my HA is P greater than P0. I think it's increasing. So what is my P0? This is the one I highlight in the pink, right? So this is my P0. That is the previous, this is a population proportion. So I'm looking for is P is greater than 7.5, right? So what is the answers here? The answer is part D here, right? So it will be my alternative hypothesis greater than 0.075. Okay, so then the next one's here is which of the following is not necessary for the Z1 population proportion? So let's take a look. So we always said here, the sample has to be random. So this one has to be there. Less than 10% of population will be sampled. That's why we want that. We don't want like a huge number of sample, then they take over the almost the whole population. The independence assumption is the truth here. So the only one we don't need is what? Is there are more than 10 success and 10 fails here. Okay, so now the next two here is the p-value and the statistics here. All right, let's go ahead and go to the calculator one more time. So make sure we know which one to use, right? So this is the one, so clear that out, do a stat, do a test. Oops. Okay, so what the test here is one population proportion, right? One proportion, what test? Z test, right? So it's one proportion Z test. So what is the population proportion? 7.5%, 0.07. So how many sample I have? 420. How many have abnormality? 34, right? So we want to see is this increasing? So it's P0. Now let's take a look. What do we have? Okay, so I will have my test statistics here is a pointer what? It will be 0.463, right? And what is my p-values here? The p-value is here, right? So it's a pointer what? 0.3216. All right, so let's go to our exam, see where we are. Okay, so we just did, right? So let's write it. So we know the test statistic Z is equal to what? We said Z, the test statistic is 0.463. Do we have a 0.463? Oh, yes, here. Then we also wrote down the p-values here from the calculator is 0.3216. So do we have a 3216? Oh, yes, here, right? So the answers here is the p-value here. Now the conclusion, like I said, I typically don't want to look at conclusion before I make the decisions, right? Because then it will confuse me. So in here, we said the p-value is 0.3215. It's pretty big, right? It's bigger than our typical 0.05. That's my significance level. If it's bigger than what we said here, so if you write it down, so we said fail to reject H0. Okay, so now you go back to your hypothesis here. They said fail to reject H0. That means you still stayed in the H0, right? So that's what is your conclusion. Okay, so now I can read it. You can read the conclusion and go to check the answer and say data does not provide significant evidence to support percent of the abnormality will increase. Right? So let's see which one is that. So fail, so okay, so we fail to reject. All right, so let's, okay, so we fail to reject. All right, so this is the right statement. Then let's see the reject the H0 is P equal to the 0.075, right? So let's see, there is a sufficient evidence that's more than 8.1% of the nation children has genetic abnormality. That's not what we say. We say we're going to state it here. So let's say second one is here. So reject H0. No, we failed to reject, right? Okay, so I know then the D is reject, so cannot be. So this one maybe, let's see, fail to reject. So there's no sufficient evidence to say more than 7.5. So that is true. That's why we are still staying after this hypothesis. So the answer will be C here. Okay, that's it. So I hope that you will be able to distinguish. So mainly for this midterm, we are talking about 4 different tests, right? The one population proportion, 2 proportion Z test, then 1 sample mean test. So we have the Z or T, depending on the population. Sigma is known or unknown. All right, that's it. And so hope this help you to prepare for the exam number 2. And good luck for that, okay? Talk to you later. Okay, bye-bye.